Okay, let's answer number 6. A large hollow plastic sphere is held below the surface of a freshwater lake by a cable anchored to the bottom of the lake. The sphere has a volume of 0.300 cubic meter and the tension in the cable is 800 newtons. Calculate the buoyant force exerted by the water on the sphere. Okay, so we are given the volume of the sphere. This is equal to 0.300 cubic meter. Okay, if this is the volume of the sphere, this would also be the volume of water displaced. Okay, this is Archimedes' principle. Okay, number one, the statement number one. Okay, so it says calculate the buoyant force. We know that the buoyant force can be computed from the mass of the water that was displaced. We use this formula to compute for the mass of the water that was displaced. So you are given that the density of water is 1000 kilogram per cubic meter. Multiply this with the given volume, 0.300 cubic meter. Okay, we get 300 kilograms of water that was displaced. So from here, we can compute the buoyant force, okay, by just converting this to newtons. So 300 kilograms times 1 kilogram, 9.8 newtons. This will give us 2,940 newtons. This is already in 3SF. The given is volume is in 3SF also. Okay, so 2,940 newtons. What is the mass of the sphere? To get the mass of the sphere, we have to know the weight of the sphere first. So we have to do a sum of forces along the y-axis. There is no movement since it is anchored below the surface of the freshwater lake. So sum of forces along the y is equal to 0. Let us illustrate. Okay, so this is the bottom of the lake. There is an anchor moving down, and this is the large hollow plastic sphere. Okay, there is an upward force, we call that the buoyant force. There is a downward force, we call that the weight of the hollow sphere. And then there is a tension pulling this cable downward. So this is negative, and there's also a tension. This is the cable pulling it downward. So we do the sum of forces along the y. What are the forces along the y? You have negative T, which is pointed downward. You have BF, which is moving upward. And you have FW, okay, directed downward. Okay, they are equal to 0. So the tension in the string, you are given that the tension in the cable is 800 newtons. Okay, let's put it here. And this is 800, negative 800 newtons plus the buoyant force we computed a while back, 2,940 newtons minus Fw is equal to 0. We expect this answer to be negative, yung Fw natin. So Fw would be equal to 2,140 newtons. So use your calculators. You will get negative 2,140 newtons. Okay, from here, tinatanong yung mass ng sphere. We just convert this to kilograms. So the mass is equal to 2,140 newtons times 9.8 newtons, 1 kilogram. So the mass is equal to 218.3 kilograms. Okay, so our answer should be in 1SF. Therefore, this one would be 200 kilograms. Okay. There's a question letter C. The cable breaks and the sphere rises to the surface of the lake. When the sphere comes to rest again, what fraction of its volume will be submerged? Okay, so naputol yung cable, so umangat, no, lumutang. Ang tinatanong niya ngayon, what is the fraction. So we need to get the specific gravity, okay? So first, before we do that, you have to compute for the density of the large hollow sphere. It's equal to mass divided by the volume. The mass we computed as 218.3 kilograms here. Okay, it's already here. Na-compute na natin, ano, ito, 218.3 kilograms. We substitute it here. So this is 218.3 kilograms divided by the volume, 0.300 cubic meter given in the problem. Okay, so this will give us 727.89 kilogram per cubic meter. Okay, we compute for the SPGR. The SPGR is 727.89 kilogram per cubic meter divided by the density of water, which is 1000 kilogram per cubic meter. This will give us 72.7. Multiply this by 100, you will get 72.7% submerged in water. Okay, in the freshwater lake. If we follow the rules on significant digits, this would be 3SF kasi yung given is 0.300 cubic meter. Okay? Number 7. Stone has a mass of 500 grams and has a density of 2.00 times 10 raised to the third gram per cm cube. So it's CGS to, no? It is suspended from a string. What is the tension in the string if the stone is in air or if it is completely immersed in water? So pag nakahang. In here, we are given the mass and density. We can compute for the volume. Okay, the volume is equal to mass divided by density. Okay, the mass is 500 grams. 500 grams divided by 2.00 times 10 raised to the third gram per cm cube. Your answer will be in cm cube. No? So 0.25 cm cube. Okay, this is the volume of the stone. And this is also the this is also the volume of the water that was displaced. So letter A, tinatanong niya, what is the tension in the string if the stone is in air? If the stone is in air, uh, it the tension in the string would be based on the weight of the stone alone. So 500 grams times, okay, we know that in the CGS system, 1 gram is 980 centimeter per second squared. Okay, so 500 grams times 980 cm squared. Okay, let us compute that. So 500 times 980, you will get 490,000 dynes. Kasi large numbers talaga ang dynes. No? So this would be the tension in the string. Why do we know? Because there are only two forces acting on this. Okay, you have the tension which is upward and the weight downward. They are balanced, so tension is equal to FW. Okay, letter B, what if you place this and immerse this in water? Okay, so in this case, it's no longer going to be just two forces, but you have buoyant force. No? So sabi niya, what is the tension in the string if it is completely immersed in water? Pag completely immersed in water, there is tension upward, there is buoyant force upward, and there is weight downward. Okay, it's equal to 0. Okay, we are computing for the tension, so tension is equal to the weight of the object minus the buoyant force. Okay. We get the buoyant force from the volume of the stone. Okay, from here, we can compute for the mass of the water that was displaced. So M is equal to the density times the volume. So density of water is 1 gram per cm cube. Okay, density of water is 1 gram per cm cubed, and the volume of water displaced is 0.25 cm cube. This will give us 0.25 grams. Okay, that's 0.25 grams. Now, 0.25 grams can be converted to dynes by multiplying it with 980. Okay, so 0.25 grams, you get 245 dynes. Okay, so converting this to dynes, you get 245 dynes. So this is the buoyant force exerted. Liit lang siya. So the weight of the object is 490,000 dynes. Check natin na. Minus the buoyant force, which is 245 dynes. The tension that would be felt. Liit lang, 490,000 dynes. Okay, let us see. And the answer that you are going to get is 489,755 dynes. I think, please try this question out. Okay, number 7, if we change this to just 2 gram per cm cube, I think this is the correct. May mali dito sa data niya. There should be no times 10 raised to the third. This would be more realistic, no? Kasi the density here is quite big. Okay? The times 10 raised to the third is usually associated to kilogram per cubic meter. Okay, so somehow siguro there's something wrong with the 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 way I copied this question. Okay, so please change. But the solution process is correct. You just change this times 10, remove times 10 raised to the third gram per cm cube. Okay, let's go to number 8. A uniform solid cube of material 5 cm on a side has a mass of 400 grams. Okay, will the cube float in seawater? So to know this, we have to get the density of this solid cube. Okay, the volume of the solid cube can be computed by S cube. So 5 cm on a side, 5 times 5 times 5 will give us 125 cm cube. Okay, it has a mass of 400 grams. Okay, 400 grams yung mass. We can compute for the density. So density is equal to mass divided by volume. 400 grams divided by 125 cm cube. What do we get? Okay, 400 divided by 125, we get 3.2 grams per cm cube. Now, since the density of the cube is greater than the density of water, okay, the cube will be submerged 100%. Okay, so totally submerged siya. So the volume submerged will be 100%. Okay?